Okay, guys, well, this is J, this is 15J, and we're moving on to chi-squared tests for independence. This is pretty quick to do on your calculator, in fact, but there's a few things that you definitely need to be aware of here. One thing that you don't really need to be aware of is the chi-squared, that's how it's written, like this massive kind of X. So chi-squared test statistic, which they give you here. You don't really need to be aware of that because you do everything on your calculator. But at the end of this video, I'll try and show you how that works using Excel. So yeah, that's what we'll do. Okay, there's another couple of really important things here as well. What you do need to be aware of is the degrees of freedom. We'll talk about those as we go through the problem. Essentially, the number of rows take away 1 times by the number of columns take away 1. And you also need to be aware of, hidden here somewhere or other, that all of your values in your table should be greater than 5. Make sure that you know how to find the expected values on your GDC, as you will need to check them each time to make sure they are all greater than 5, right? So it's the expected values, not the observed values, if I said that. The expected values, which need to be greater than 5 once we make our table, right? This may seem as clear as mud at the moment. So let's just look at the question. Here's the type of question that you could be given. We've got categories of music here, and down the other side of the table, so two-way table, we have the other variable, which is gender here. And what we're testing for is to see whether or not the choice of favorite music genre is dependent on gender or not. So the null hypothesis here would be to say that these two variables are independent of each other, that whether you are male or female, it does not matter as to the choice of music that you like. Okay, so that's the null hypothesis, and the alternative hypothesis is, of course, to say that your choice of music depends on your gender. Okay, so I suppose you could say it the other way around. You could say your could you say it the other way around? your gender depends on the music which you chose. Not sure. Okay, right. So let's look at this question then, and it's pretty straightforward. There's a couple of other things. Obviously, it's written like this. It's kind of like this, like a curly line, and then a line which crosses it. That's chi from the Greek alphabet. It's spelled C-H-I, so some people say chi squared. I believe the pronunciation is chi. Okay. Right, so let's have a go at this then. So let's get rid of me. No, let's keep me actually. Let's keep me because it's doing all this on the calculator. So write down the null and alternative hypotheses. We've already talked about those. So H0, favorite genre of music is independent of gender, and H1, favorite genre of music is not independent of gender, or in other words, is dependent on gender. Okay, part B, show the expected value for a female liking pop is 21. Okay, so basically imagine that you didn't have any of this information in the center here, and you're having to make an estimate for the numbers which go inside, depending on these values on the outside, and of course the totals as well. So for example, half of all people prefer pop music. Okay, so 40 out of 80 people in this survey preferred pop music. So you would expect a half of the people to be preferring pop music in this case. So that's a half of 80 that we have in this column here. But then also, so that's 40 out of 80 of 80. Okay, so a half of 80 is going to prefer pop music. But also, there's a split between male and female here. So if we wanted to know, say, for example, the number females who like pop music, we also know that there's slightly more females in the survey. So we'd also expect them to be slightly more represented in that section as well. So we'd say, well, and of those, so this would be the number of people who like pop music, a half of 80. And then we'd say, well, then times by the fraction who are female. Okay, so 42 out of 80 there. Now you can write that in whatever way you like, but it's essentially the fraction of pop music times by the fraction of, sorry, in this case, female, because that's what they're asking for, female, and then times by 80, the total. Okay, so let's just get rid of some of this. So now, obviously, you can do that for every single one, but it's going to take some time. So there's 8 different expectations which you could find there. Now, some of them are going to be whole numbers, and some of them are going to be decimal numbers. And it is okay for you to use 3 significant figures in your answer if it's a decimal number there. Or if you're going to use those calculations later on, obviously use more significant figures. Okay, so again, let's look at the answer for this one. They've said 42 over 80 times 40 over 80 times 80 gives us 21. Okay, done on that one. So let's just recap. You know, if we wanted to find the number of males, expected number of males given the totals, okay, if we wanted the expected number of males, we'd say 10 over 80. So that's 10 out of 80 here, times by 38 out of 80. So that would essentially be the probability, and then times by the total number of people to get an estimate for your expected value there. Okay. Right, now obviously, again, as I said, you can do this 8 times over, but your calculator will do this for you. It's pretty neat. Okay, then it says find the full table of expected values, right? So this is where we can go to our calculator. Now, strangely, we need to do this. We need to do the test first, and then we're going to get the expected value. So we need to do this in the wrong order. So on the calculator, so again, I'm using the TI Inspire in this case. I'm going to calculate, and I'm going to put in my matrix. So I'm going to go menu, and 7, which is matrix and vector. And I'm going to create a matrix, which is 1. We create a matrix which has 2 rows. I'm going to tab across to the number of columns. Number of columns is 4. I'm going to tab across to OK. And then I'm going to put in my numbers which are there. So I've got 18 and 22. I've got 9 and 6 and 3 and 7 and 8 and 7. Okay, so there's my matrix. Okay, there's the matrix up. You can see I've already just done this. I'm doing it again. Okay, so before I press equals on that matrix, I'm going to say control and store this as A. Okay, so you can see control and variable gives us the store arrow, and we'll store that as A. So let's store it as A. It just repeats the matrix there when I press enter. And then next I'm going to go to the test. So I'm going to go menu and statistics, so 6. Stats tests. So we're doing a chi-squared test for independence. So stats tests. And you'll notice that chi-squared is mentioned twice. There's a goodness of fit test, which we're going to do in another exercise. And there's a chi-squared 2-way test. Now we want the 2-way test one, the test for independence. So let's click on that. So that's number 8 for me. And the observed matrix it asks me for, which is A. So I'm going to go OK on that. And then it gives me all of my results. Okay, so there's all my results. Okay, now I haven't got my table of expected values at the moment, but now that I've done that and I've defined my variable, I'm going to press variable, and I'm going to press, and you'll see there's a whole list, right? I come up with variable, and it comes up with a whole load of stuff. Okay, and what I want is stat expected matrix. So we go down to stat expected matrix. So they're going to do the expected matrix given that I've I've inputted my matrix into the calculator. So it's based on the last matrix which is there. So let's do that. Let's press enter on that one. And you can see it just says stat expected matrix. I mean, potentially there's a way of putting in A. I don't know. But if you've already put in A, it will make the expected matrix here. So there we go. We've got it. Okay. Stat expected matrix, and there it is. Okay, so we've done everything that we need to do now, actually. Find the full table of expected values. You can write those ones down. It's 19, and in this part here for classical, it's 7.125. And for folk, it's 4.75 problem, and so on. Now, there's only one number in the expected matrix which is below 5, and that's this number here. Okay, that's for folk. And that comes out at 4.75. Okay, so there's an issue. And at this stage, once we've found the expected matrix, we realize there's an issue. And we say, well, actually, you're not allowed for this test to have expected values below 5. I'm not quite sure why. I guess it's less effective. Less effective if that's the case. So the next part actually tells us combine two columns so that all expected values are greater than 5, and write down the new observed and expected tables. Okay, so we're going to need to combine two of these columns here. So ultimately, they didn't ask us to do the chi-squared test here at a 10% significance level. They haven't asked us to do that just yet. And I guess the reason for that is because it's not valid here. So we need to combine two of the columns. So we need to take that further. So all of that table of information when I did the chi-squared test is actually pointless. I wonder if I could have come up with my stat expected matrix without doing that. I'm going to check that next time. Okay, so combine two columns. So let's combine two columns. So let's combine folk and jazz. They've got the lowest values in. Or equally, I could combine classical and folk. But let's combine folk and jazz. I think they do that in the book. So we've got folk and jazz is going to be 11 there and 14 there. And doesn't really matter that I calculate this here, but that's 25. Okay, so I'm going to make a new table, a new matrix rather. Matrix 7, create this matrix. I'm going to do 2 rows and 3 columns, tab across, and now I'm going to put in 18 and 9 and 11, and 22 and 6 and 14. Okay, and I'm going to, let's say, let me just save that as A again. So control variable, so store it as A. Okay, let's go variable and stat expected matrix. Let's see if I can make that up. No, okay, so when I go stat and expected matrix, it gives me the old one. Okay, so I need to do my chi-squared test first. So now I'm going to go stats, and then stat tests, and chi-squared two-way test, observed matrix A, tab across to OK, and now I've got my chi-squared two-way test in this case. So my p-value here is something like 55%, 56%, 55.9%. It is not underneath 10%, in which case I cannot reject my null hypothesis. There's not enough evidence to reject the null hypothesis and to accept the alternative hypothesis. So we do not accept the alternative hypothesis. Okay, what else do we need to do? Combine these to find the new observed and expected tables. So we're going to need to come up with the expected table as well. So again, let's go variable and let's go stat expected matrix again. Press enter on that one. And this time around, I'm getting 19 and 7.125. So that's the same as before, of course. And then 11.8 875, which I guess is just the combination of the two rows from before. So if you see on this expected matrix, if you add together the numbers in the last columns there, you will get your new expected matrix. Okay, so there's that. Let's just check that with the book as well. So let's go down here. Ooh, why is that giving a slightly different value there? Oh no, because they're doing the first one still, I think. Yeah, here we go. On the second one, we've got 5 point, you probably can't see that, but it's the same, right? 0.559 there is your p-value. Okay, you're also given your chi-squared value, which is 1.1629. Yeah, so you're given that chi-squared value, which ordinarily what you would need to do before the advent of calculators, you would need to then refer to a table. So here we go. Here's a chi-squared table. So you'd need to compare your value, just looking at this one on the right-hand side here, you'd need to look at the critical value for the chi-squared distribution. So you'd need to think, how many degrees of freedom do we have? And I'll come back to that in a second. But how many degrees of freedom do we have? And then we need to compare our value to the critical value at a particular significance level as well. Now, they don't even have a 10% significance level on this one, but they do have the degrees of freedom. And I think in that last table we have, let's just check it out. So in the original table, we have 3 degrees of freedom. That's 1, 2, 3. That basically means to say, if you know all of your totals and you know the 18, the 9, and the 3, then you can work out everything else in this table. So you can work out all of the other missing numbers. So we say that there's 3 degrees of freedom. Now, the way to get that is to do the number of rows, take away 1, times by the number of columns, take away 1, which is obviously 4 take away 1, times by 2 take away 1, which is 3. Now, that's for this one, but when we collapse these 2 columns here, then in fact, we'll only have 2 degrees of freedom. We'll have 2 times 1. So 3 take away 1 times by 2 take away 1, which gives us 2. So, so then we'd be looking, in an old-fashioned way, we'd be looking at the critical values from a table and to see the probability of exceeding those values. If you have a large value of chi-squared, then you'd be talking about then being past that critical value and then accepting the alternative hypothesis, which is the opposite way round for the p-value. Okay, p-value is saying what's the probability of being this far away from our expected values, if you like. Okay, so let's just check through as well. Let's just recap. Have I missed anything here? Did I miss anything? Write down the degrees of freedom for the new table. It was 2. I think we talked about that. It was 3 take away 1 times by 2 take away 1. And for F, use your GDC to find the chi-squared statistic and the p-value for this test. So the chi-squared statistic is irrelevant unless they talk about giving you a critical value, which they're not telling us in this case. But the chi-squared statistic was, I can't remember, what was it? It was 1.16 something or other. And if that's beyond the critical value, then you would accept the alternative hypothesis. But because we have a p-value approach on the calculator, we can simply say that the p-value of 56% is not less than 10%. Therefore, we do not accept the alternative hypothesis here. And there we go, we're done with this question. Okay, so that's done. You can have a go at the exercise. You can ignore the rest of what I'm about to do here, but I kind of want to take forward the the formula. Okay, so let's go to the formula here and let's do this one. So this may take a little while. You can flick ahead if you want, or you can just stop if you want as well. So here's the chi-squared statistic. So I'm going to use Excel here to work out. There we go. Just make that a little larger. Let's make the entire sheet a bit larger. Okay, and I'm going to work out from the table. Where were we on that question? What did we have? We had, actually I've got it here. So I'm going to put this information in as well. So we had 18, 9, 11. Okay, so 18 and 9 and 11 there. And we've got 22, 6 and 14 there. So that's the table which we're testing. We need some expected values. Now, we can come up with the expected values pretty simply from here as well. So there we go. So let's copy and paste that. Sum of these. Okay, so sum of 80. So we're going to make the expected values, and expected values in this case is going to be, let's do this times this divided by 80 cubed. Why is that not working? Divided by 80 twice. And that should work. What am I doing? Wrong thing. Okay, sorry. So 80, let's just write it formally. Okay, so times 38 out of 80. And then 80, and then times by 80 here. So there you go. So we've got 19 there. Okay, and then if I just change this, I want to say fix it to, what do we do here? It's kind of tricky. What do I want to fix here? I want to move it across. So I want to keep it in. I want to fix it to E, don't I? So fix it to E. Sorry, going a little slow here. Okay, and then I want to fix those ones to the bottom as well. Let's just do this one separately. I'm not thinking clearly here. So then we've got this divided by 80 times, what are we doing? Boom. E6. Hang on. I'm fixing E there. Maybe I need to fix 5 here. Let's just try that one. And then there we go. I think I've sorted it. Okay, there we go. Right. Okay, and so then we're going to do this calculation here. So we've got here then F0 take away FE. So let's do the observed. So this is observed here. This is expected. So let's do another table of observed minus expected. And that should be fine just to copy across there. So it's observed minus expected. Now we want to do those things squared. So again, I'm going to just do another table. These things squared. And we've got all those things squared. And then we're dividing those by the expected. So we've now got these things divided by the expected. Obviously, I can do all this in one go, but doing it one by one. There we go. So there's now the observed minus the expected squared, and now divided by the expected. Now I need to do the sum of all of those. So let's do the sum. These copy and paste that one, and then let's do the sum of these ones here. Okay, should give me the 1.16, I think it was. There we go, 1.16. So there we go. That's the value that your calculator is getting. And if we then wanted to compare that to critical values here, we'd need a critical values including the 10% level with 2 degrees of freedom. And so, because we're doing a 10% significance test, so we'd be comparing it to the value of 4.605. And since we're not beyond that value, because of course we're not getting high differences from the observed, between the observed and the expected, since these are not particularly high values when we sum them all together, therefore we do not reject the null hypothesis in this case. In other words, there's not enough evidence to say that these things are dependent. Okay, guys, thank you for listening. And yeah, good luck with the exercise.